everyone, I am Saniya and in this video, I'll be talking to you about how you can condition on two or more random variables for Bayes' theorem. So this is me, Saniya, and this is cute little Yangshi. And we're going to walk you through how you can do this when you have multiple variables that you want to condition on for Bayes' theorem. How do you do that? How does that work? Here is the joint probability distribution for A, B, and C in this example. So we can see that A is false, B is false, and C is true. And the probability of all of that is 0. Of A being false, B being true, and C being true. All of that is 0.3. The probability that A is true, B is false, and C is true is 0.2 or 20%. The probability that all three are true is 20%. The probability that all three are false is 30%, 0.3. The probability that A is false, B is true, and C is false is 0. The probability that A is true, B is false, and C is false is 0. And the probability that A is true, B is true, and C is false is 0. So this is the example joint probability distribution for the A, B, and C, 3 Boolean random variables. So in this case, how do you, for instance, deal with a problem where it's asking you to compute the probability that A is true? Given that, so again, this point in probability, this is the given. Given that means that given that B is true and C is true, how do you find the probability that A will be true? So if we know that B is true and that C is true, what is the probability conditioning on that? The conditional probability, right? What's this probability that A will also be true? So that's what we want to find here. And here we have multiple. We don't just have one. We have multiple. We have B and C being true. Yeah. Okay. So what we're going to do is, so this is using Inspector Gadget, which is one of my brother's favorite movies growing up. Da 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 da, Inspector Gadget. So we're going to look here. So what we will do here is we're going to look in this probability table of 8 outcomes and see where not just B being true, but where is C also true. So we see B being true here and C being true here is 30%. And but A is false, and B being true here, and C being true, but A being true is 20%. So it doesn't really matter here. In fact, the guide is just going to zoom in from all these 8 different outcomes, and these outcomes all sum up to 1. Out of those outcomes, we're just concerned and where B is true and C is true, that's 30%. And then where B and A is false, and then where A is true and B is true and C is true, which is 20%. So we're just concerned where B is true and C is true. Right now, it does not matter what is the outcome for A. We only care at B being true and C being true. So when we add this together, 30% and 20%, this point right here is going to be 50%. So we restrict it, and in fact, we get rid of everything else. Cut this part out, we cut this part out because both of them are not true, and this part out. That's what we will do. So basically, for those of you who are visual learners like me, Yangshi, we are visual learners. He's not hungry. So what we're going to look at is B being true over here and C being true over here. So this green circle is when B is true, and this purple circle is when C is true here. Hi, me. And what we're going to then look for is the overlap between B and C being true. And we're going to find that indeed it's this circle here. So we're going to see from here when B is true, when the part where C is true is given by this part here. And similarly, this is the overlap between B and C. And that's what we find over here, B and C, this overlap. This overlap is 50%. So the probability then that B and C are true, or just B and C, is just equal to 50%. That's what this is, 50% here. That's the overlap between them. And this is our new sample space. If we were just conditioning on one of the variables, Yangshi, if we were just conditioning on one of the variables, it could have been just like the circle like this, like before when we were doing the simple one-to-one. Now that we have two variables, we have to look at when both of them are equal, and that's given by this I-shaped, I-shaped kind of overlap between them. So basically, this is what we're looking at. Now what we will see, this is the 50% that I was talking about. You know, it didn't matter. It didn't quite matter whether A was false or true. We only cared here about B being true and C being true. This was the 50% over here. This was the 50% right here. And now that we have this sample space, we want to see what is the probability that A will be true. The probability that A will be true will be given by this 20% here. This 20% is the overlap between this in this point here. What we will see is that we look at where the orange part, where does this orange part cut that overlap between B and C, this point right here. And the part that is falls within this orange circle is given by this 20%, which is basically the overlap of all three circles in this case here. This yellow point here, this is the probability that A is true, B is true, and C is true. Because whenever you're in that small little circle, all three of those variables are true. So that's what we want to look at. So basically, we want to see the probability that A will be true. So we look here, this is the probability B is true and C is true, regardless of whether A is true or false. And in Bayes' rule, the truth is that you're seeing that we're conditioning on this one thing, B being true and C being true. And that's what the denominator is going to be. The probability that, B is true and C is true. And that's sort of what happens in the numerator. We look at where B is true and C is true, but then we also add in A being true. So for the numerator is basically saying, hey, whatever you have, whatever you're conditioning on, I want to put an and here. That part becomes the numerator. So the numerator is basically saying A is true and B is true and C is true. So it's the same thing as the denominator, only it's saying that you have both of these conditions here in the denominator. In the denominator, you're looking at this 20% here, which is when A is true, B is true, and C is true. This 20% right here, which is also what this is. But you are also considering the case when A is false and B is true and C is true, which is 30%. This 30% is right here. So in the denominator, you're considering both cases as long as B is true and C is true. That's what you're considering. So basically what we're going to then see is that the numerator is more restrictive because we have A being true, B being true, and C being true here, which is going to be just the 20%, which is also in the denominator, but the denominator also considers the case when A is false. So basically for the denominator, what you could have is you can have A can be either true or false. It doesn't matter. You're considering A is true or false. It doesn't matter. The only thing that matters to you is actually that B and C are true. So again, as you see here, that we're adding the case that A is false, but B is true and C is true. This 30% right here, We add that here along with the case when A is true, B is true, and C is true, this 20%. So we get is 0.2 over 0.5, which is 40%. So in Bayes' rule, what you're going to notice is that whatever you're conditioning on, so given that B and C are true, you reduce your sample space to this area right here. You've reduced it down to this spot right here, this little overlap between them. And so I'm not that good at drawing, but you reduce it to that sample space right here, which is the probability that B is true and C is true, the overlap of both of these circles right here. That's what this is. And then what you're looking at is you're looking at this yellow part, which is when A will also be true. So whatever you've conditioned in the denominator, you're looking at the probability that A is also true. And that's sort of what this will become then. So you're going to look at the 20% divided by the 50% here, and that's going to be 40%. So that is the probability, that is a conditional probability that A is true given that B is true and that C is true. So that's how you do Bayes' rule. You sort of see what are you conditioning on in the denominator, and then you add that up. You just focus on B and C. It does not matter again what A is. So you've added the value when A is false here, and when A is true here. But in the numerator, that's when you're sort of concerned about the probability that A is true. So the numerator will always be a subset of the denominator because you're sort of being more restrictive. So you're saying, okay, this is our sample space for the denominator, but I also want to focus on this part. So the numerator sort of looks something like okay, so just let me show it that way. So the numerator actually is this part right here, this 0.5. Oh, that's the denominator, is a 0.5 right here. That's what this 0.5 is. And the numerator is just going to be this part out of that. It's just going to be the small little part out of that. That's what the numerator is going to be. So out of that, it's just the 20%. That's actually what the numerator is going to be. This 20% slice out of this 50% here. So it's going to be a subset of that. So that's the probability A is true given that B is true and C is true. So you just have to, it's the same analogy as for dealing with conditioning on one random variable. You just have to notice when if you have multiple random variables, just see when they all have those outcomes, whether it's true or false. Just see the intersection of those values that you're conditioning on for those. And that's your denominator, and then the numerator just says whatever you are trying to look at here, the probabilities A is true, you're conditioning on this part over here and you're just adding it on. So you're saying given that all this is true and I just have this criteria that I want to figure out, so I'm conditioning on B being true and C being true, and we could have also conditioned on B being false and C being true, or B being true and C being false, or both being false. And we can condition on anything, but whatever we are conditioning on, given that we're adding in this and then that's what we're trying to say, that this is also happening, like, you know, this is the situation and we just want to see this happening and this happening, given that. So you add this and is very important here. This and is sort of, oh gosh, this and is kind of telling you how you can connect them together. This being true, and whatever we thought would happen, that happening too. A being true and B being true and C being true divided by the same thing. So you just see that this is the same. And I'm just going to kind of show you again without all the annotations here, just to show you again that this is just taking this part right here and you know, given that this is true, this kind of, you can think of it like an and but this is actually representing given that. And then this part right here sort of becomes the denominator, and it's also found in part of the numerator, and it's sort of what you are conditioning on. So again, that's just what you see here, this 0.2 divided by this 0.2 plus this 0.3 here, divided by this. 50%, so it's 20% here, divided by this 50%, and that's 40%. And these can be both, again, B can be false or true, and C can be false or true, and you're just going to condition on those. So for instance, if B was false, then how it would look would be the following. So again, in the case that if B were false, for instance, and you would just say, okay, well, this is the probability that B is true. So I'm just going to look at everything shaded outside of that, and that's the probability that B is false, actually. So then you would want to look at the intersection. So sometimes if it's hard for you to visualize what's going on, I recommend if you have 2 or 3. Otherwise, if you have 4, it gets kind of confusing. But if you have 2 or 3 random variables, it's much easier if you put it in a Venn diagram like this. And I have another video that I prepared on how you can make a Venn diagram corresponding to those random variables, 3 random variables. So please do check that out. But here you can just see that if this is the outcomes you're looking at, if B is false, then it's sort of like everything outside of the circle. So you can also condition on B being false, maybe C being true. In that case would be in that case, if we're seeing, okay, C is true as well, then what that would be is that would be the intersection of this green part here with this whatever's inside the circle. So that would be this part right here, everything here. Because that falls within the circle of C, but it falls within this green shaded part of not B. So that's how you would figure out, and then that's the probability of, and probability of C equals true, and B equals false, is just going to be given by, it's just going to be equal to this 0.2 that we see here, this 20%, plus this 0. So it's just going to be 20%. And so similarly, that's how you can kind of work with those examples and then condition on them. And then this is this region, and if you want to find that A is true given all of that, then that's just given by 20%. So you can use a visual, or you can use the joint probability distribution table and just see those outcomes that way. So either way, if you're a visual learner, or if you like to see that table out, that way, so whichever way works for you. But I want to show you that you just have to sort of condition on whatever outcomes, given that that outcome happened, that becomes your probability of that outcome happening becomes your denominator. Then your numerator stacks onto that, and it adds its own conditions that I want to find the probability of A having a certain value given that. And that given that sort of means that, okay, this outcome, C being true and B being false, this outcome is sort of what we're having. And I want to then find the overlap and find the probability A is true, for instance, and that's what this is going to be. The A is true is going to be this part right here. A is true given that B is false but C is true. Then that would be 20% divided by this part over here, and that's going to be 100%. So this is 0. So that means that if B is not true, but C is true here, then it means that A is 100% going to happen. So that's 20% was this part, but the probability that A is true then given that and B is false, that's just going to be equal to 100% 20. So that's for sure going to happen. So you typically see that the probability that A will happen, given its A circle, is 20% plus 20%, which is 40%. So from 40% chance of A, we now have 100% chance of A if C is true but B is false. So I know these zeros are misleading here, but that's sort of an example from one of the earlier videos on Bayesian networks. So I just decided to stick with this for completeness. So you might have some non-zero values here typically, but it is what it is. So typically, that based on this probability distribution, you would just see you'd see the overlap here, and then you're going to focus on the probability that A is true and C is true and B is false, that's what your numerator is, divided by this probability here, which is 20%. This probability right here, which is the 20%. Oh gosh. So I hope that this was helpful for you, and please let me know if you have any questions at all. And if you found this helpful, please do subscribe. Thank you. So in general, this is how you can use Bayes' rule. Hi, Lily. Oh, hi, Lily Booties. Oh. What you can see is the probability of A given B is this way. Oh. And how you can just add up these probabilities. This probability is the probability of A and B. And this part right here. Oh. Okay, bye little booties. This little probability right here is going to be the probability of not A so this over here just means it's just not A. That's what this means here. And what this part here is, this part is just going to be, this is going to be probability of A and B. So the most important thing right here is that essentially this is A and big B here, and this is B here, but you're just sort of adding any outcome. This for this is the probability of B. In this case, this is the probability of A and B, probability of not A and B. So you're getting all the ways that B can occur. It doesn't matter whether A is true or not. Not A is the same thing as saying that A is false. So that's just another take on Bayes' theorem for you guys. So I hope that was helpful. Aww. This is little booty saying hi. Hello. It's just a little kitten. Aww. Thank you for watching. And please subscribe.